So the next one is up right away, and who we are going to have next. So speaker talk, also cranking the buttons, and sometimes it just fell short. So next we are going to have Ayesh Kura. He's need to teach me his last name. Karunaretn. He need to teach me this one. Yeah, he's a full stack traveler. I really love his title, and not falling short of his title. His talk is how to eat an elephant. Really? How to modernize your legacy PHP applications. So please welcome, yeah, Ayesh. So pressing the buttons. Yeah.
Hi,
Oh, how are you?
good,
So
really good.
I really messed up your last name. So pretty much
Yeah,
teach me.
I'm sorry about the last name. Like everyone kinds of have their own pronunciation. It's Karuna Ratna.
Okay, not what I
Yeah,
supposed to.
it's right.
I
It
wanted.
means in my native language, it means I'm kind.
Okay, okay.
So
You
yes,
feel
maybe.
yeah, it feels right. Feels right. Thanks for not argue that much of bashing your name.
Uh,
So glad you are here. How are you today? Are you
good,
enjoying the
really
day?
good. Sorry.
Are you enjoying the day?
Yeah, really good talks today. Yeah, nice lineup.
And I'm really curious about your talk. Are we really going to eat an elephant?
I mean, not really. That
Oh,
it's based on someone else's life wisdom, but we try to use it in
yeah.
PHP. So let's see how things work out.
Let's see how it goes. So I'm going to add your screen and
Okay.
let's go through. See you in a
All
bit.
right. See you. Um, okay. You can see my slides, yeah?
Yeah, you can see it. It's all
Okay.
good.
Perfect.
Carry on. See you in a bit.
All right. Hi everyone. Welcome to the fifth session of the day. This is modernize legacy PHP applications, the way we eat an elephant. So before I start, sorry, before I start, this is a very loaded presentation, as in it's very dense. If you would like to follow along, the slides are online right now. In case you, because there's so many code snippets and stuff. If you would like to follow along, it's available to download right now. Like I said, my name is Ayesh Karunaratne. Don't really worry about the name. I was born in Sri Lanka, but I was in the Netherlands before the pandemic. But I moved to Vietnam after for around 3 years now. I work on PHP.watch. I write about what's new and changed in PHP, about PHP 8.3 that comes out in 6 weeks, and also about 8.4 that comes out in next year. So very excited to talk about modernized legacy applications. There's a saying that there's only one way to eat an elephant, one bite at a time. This is from the late Archbishop Desmond Tutu. It's about general life advice that when there's something that feels overwhelming, or when there's a task that feels so big to start, you start anyway, and then you do one small steps at a time, or one bite at a time. But this is not Dutch life conference, this is Dutch PHP conference. So let's see how we can use this life advice to PHP to modernize our old applications. Disclaimer, no animals were harmed in the making of this presentation, so it's just a way of giving good titles to presentations, I guess. Modernize legacy PHP applications, but what exactly is legacy PHP? If you have something that looks like this, it's probably legacy with all of your static files jammed into the same folder. You probably have db.php or db.inc files that will create a database instance just by calling this PHP function. you might have all of your configuration values baked into this function, to this file. So stuff like the host name, the name of the database, sometimes even stuff like secrets that should not be in the file because they're sensitive values, but they're in the file already. You might have small template files, for example, part of a PHP file that's supposed to be included from somewhere else, but they are individual files. Sorry. But also, you have variables that come out of nowhere. The site name variable, where are you supposed to get this variable? Or stuff like the name of your site itself. This doesn't feel like configuration, but it's something that's hard coded, and it makes things very hard to modernize or very hard to change in the future. This is another pattern I saw. Libraries on PHP, extensions, libraries, whatever you call them, there you just download the zip file, shove it inside the same folder, and then no one checks them back. If there was a new update, there's no way to know it unless you do this again manually. There's no way to see if someone else modified these files. And these files, like for example, PHP mailer, you have to have include phpmailer.php call just to include this file again. And then we have files that look messy like this because they tend to change the application state. For example, here, it just by including this db.inc file, it creates a database connection, and it also has template layer baked in. It also has different ways of showing things. These are very old ways of doing things, old and kind of messy ways of doing things. And these are the very things that we are going to modernize. And the other pattern is we have global variables, not just get and post values, but also things like the database connection itself. How do you get this database variable? No idea, but it just happens to be here. And then you have to know the order of the files that you include one by one. And if you have someone else coming to this code base fresh, they have a hard time figuring out where this file should be. And if you see a global variable, that's a very good sign. There's so many things that you can improve. So that's a good candidate. And these variables, part of the reason why we have this messy structure is actually PHP. If you're using PHP 5, any of the PHP 5 versions, you probably don't have namespace support. That came out in PHP 5.3. So all of the code is jammed into one global namespace. There's no proper separation between them, and it's generally very hard to figure out where the code is. They probably don't support autoloading, which means you probably have 200 include lines sprinkled everywhere in the code, and they have to be included in the right order. And it's up to you to resolve the dependencies. So if a class depends on another class, you have to include them just knowing the order. And all PHP versions, we didn't have a proper CSPR means cryptographically secure pseudo random number generator. So basically saying most of the random number generators were not very secure unless you use something like OpenSSL. But I mean, no one really did that 10 years ago. And you're probably missing some of the improvements in newer PHP versions. For example, PHP 7 has AST, abstract syntax tree, so you can modify the PHP code. And also in PHP 8, we have just-in-time compiler to kind of make math-heavy computations really faster. And we had to deal with things like register globals and all these old PHP shenanigans, right? If you remember register globals, that was very annoying. And again, password hashing wasn't the thing a few years ago, like a decade ago. You had to use script if we are really conscious about security, but many people just use plain text password, store them on the database, or use MD5 or stuff like that. And there was no proper exception support. So most of the built-in PHP functions, they used to return false or null if there was something wrong. But it's very hard to figure out because every time you call these functions, now you have to check, did it go okay, by checking the return value. That was an annoying thing to do. Scalar types wasn't the thing back then. So if you have a function that only takes Boolean values, it wasn't possible for you to say, I will only take Boolean values. So you had to check them inside the PHP function if the type of the value is right, which was also annoying. And we also had some extensions removed in some of the newer PHP versions. For example, MySQL, not MySQLi or PDO, the old MySQL extension. It was so insecure, so unmaintained, we just had to get rid of them in PHP 7. The same goes with mhash as well. Like, you probably didn't use mhash back then, but that was whole trouble that kept people stuck with these legacy applications. Let's also talk about libraries themselves, libraries and frameworks. They tend to get stale as well. So, for example, Zen framework. No one uses Zen. I mean, not no one. Like, most of the legacy applications use Zen framework, but they are trying to move away from Zen to Symfony, for example. But there's so much inertia that keeps you in these legacy applications because they're no longer maintained and it's not easy to migrate. You also have major paradigm shifts. Drupal, for example, Drupal 5, 6, and 7, they used to be so similar to each other, as in every time you take a look at Drupal 7 code, it could be Drupal 7, Drupal 5. You can easily port between them because they had the same paradigms. But Drupal 8 was a huge leap. It went from functional programming to mainly object-oriented programming. So it left most of the people inside. Even today, Drupal 7, released 12 years ago, is still the most used Drupal version today, even today. Just because there's so much paradigm shift between Drupal 7 and Drupal 8. And the same goes with plugins and extensions and modules as well. If you're using something that was only working on Drupal 7, unless you take so much effort to port them to the next version, you're probably stuck. And configuration management was also messy. It used to be INI files, sometimes the configuration in the database. Now they're YAML files, and the newer extensions don't use YAML for configuration. But what I'm trying to say is there are so many misconfigurations, and on the newer paradigms of configuration is kind of hard to work with. And they also tend to be tightly coupled. So this version of one library, it depends on a very specific version of another library. So it adds more and more momentum or inertia. So you have to stay on the old versions, just also very annoying. And the same goes with server software as well. Are you still using Ubuntu 14? Because I have one client who does that. And are you still using Jenkins? Because there are so many people who still use Jenkins, but it's not the most easiest thing to deal. So let's also talk about server and development dependencies. Like libraries, they also tend to get old. They get abandoned. For example, Jenkins. I mean, it's technically alive, but you don't see Jenkins every day. CentOS, it just went kaput. There's no CentOS anymore. Well, there is, but it's not the same. SVN, you're probably stuck using SVN, and you're probably wanting to move to Git, but there's so much legacy software that keeps you inside the loop. Lack of proper Unicode support. This is a very annoying thing personally for me. Now that I'm living in Vietnam, MySQL, all of the MySQL 5 versions until 5.7, and MySQL 8 came after, all of the MySQL 5 versions have a default that does not support Unicode characters properly. So every time I type something Vietnamese on a MySQL 5.7, I really have to think, is this going to blow my things away? And it's always annoying to deal with. So the things like this, they keep you inside this legacy software, and these are the things that we will have to address. And just because you're using old software, you probably can't enjoy the newer features as well. You really need to use Apache 2.4.17, I think, to use HTTP2, for example. And with old software, you probably can't move away from the old Apache versions. And this is my litmus test. Ask yourself, if you have application, can you make how long it takes for you to make a development server? Sometimes it's just impossible because there's so much configuration values baked into the code itself that depends on a very particular server. So it keeps you inside the loop with no way of easily creating a development server. Sometimes it depends on other software that wasn't very well communicated. And again, they are tightly compatible, and they tend to be not coupled. They tend to be too much coupled within each other, and they are not very compatible with newer software. And the same goes with people and organizational structures as well. Because if you have application that was running for 10 years, which means you have probably people working there with various levels of expertise. They have various areas of expertise. So every time you need to modernize something, there's always resistance. And people don't really like to change things. And changing things like this takes money, and you need to be highly motivated because modernizing is not the coolest thing to do. I mean, it's effective, but it's not the coolest thing to do. You're not going to use the next new hype technology. So there's motivation and funds that will keep you inside as well. But my question is, or my answer, or my argument would be, why modernize and why not rewrite? Because, like I said, it sounds cooler to rewrite something with the newest PHP version, the newest use Kubernetes everywhere, use microservices. It sounds fun and exciting to do, but here's the thing. Just the fact that your old software was running for 15 or so years, it means it's already serving the business purpose. It knows all of the edge cases of the real life businesses because real life is always complicated. The real life doesn't have to adapt to the software. The software has to adapt to the business, right? So we have a software that is kind of complicated and is kind of legacy, and it's partly because the business itself asked for it. We have so much familiarity with the old software because it was running on our business for 10 years. And it's also the practical thing to do because when you're modernizing, if you stop modernize this process halfway, you still have a software that's better than the software that you started with. But if you're rewriting, you have to go all the way to have an account for all of the edge cases. And if you don't do this, that's a waste of time, that's a waste of money. So modernizing a very legacy application is most likely the most practical way, and it's most likely the right thing to do. So let's talk about how do we modernize, and this is the juicy stuff of the presentation. I will talk, break this to 8 steps. So first we will talk about the directory structure. Like I said, we had the messy directory structure which we will try to optimize. We will consolidate the configuration files. We will start to use Composer and auto-loading in case you are not doing this already. We will double-check our error handling and try to use more exceptions where they are appropriate, and then use global error handlers as well. We will consolidate our classes and functions to neatly organized individual files, individual classes, and then we will also optimize them to be used with dependency injection, which we will talk about in a second. We will also separate the business logic from the view logic. So the idea is we don't, in the view layer, you are not supposed to go fetch anything new. So the view layer is strictly to present things. And the business layer is only to do the actual business things. It will not show any data. It just creates a structure, and then the view layer will take care of how do we show these things. It's very, the concerns are separated, and it's really neat way to do this. And finally, we will use what we call a front controller. Instead of using multiple files, we will try to route everything through the same front controller. So it's easy to modify every time we need it, and then we can share most of the code between individual page requests. So let's start with directory structure. Remember the code, the file structure we had before? It looks like this. So you have a browser that asks for a file, and the web server will go fetch this file. So in this example, it's asking for styles.css file. It's asking for styles css/styles.css file. The server will go fetch it from here and then send it back, normal. And if you have a request for JavaScript files, the same thing. But if you are requesting a PHP file, the web server will look at this file, know that you have to process this through PHP, and ask PHP to run whatever PHP code we have in there. That's usually okay, except this file, db.inc, it says PHP technically, but it's not supposed to be called by the web server. It's inside includes, it's supposed to be part of the application and not to be called by itself. This is a very real problem. Like WordPress, for example, it's doing this even today. And you have to go with stuff like htaccess files just to prevent the web server from dealing with these files. In fact, we have a whole list of files that we don't want the web server to call directly. If you remember, like 3 years ago, there was a security issue in PHP unit. It's not exactly a security issue with PHP unit itself. It's more like a configuration problem, I guess. So the server, a user could send a PHP snippet, some PHP code to a specific file from PHP unit, and it would just execute the file. So that's an RC, remote code execution vulnerability. That was one of the easiest things to like exploit on someone, because just configuration management is so easy. We are trying to avoid things like this. So ideally, what we are trying to aim for is to separate our dependencies. So external libraries, we will have them under Composer, and all the static files, we will serve them normally, just like before, through the web server. And all the application specific files, we will put them in the folder called app/src. Now, this is highly opinionated. It's just my personal opinion, but I like to use the name app because it comes to the top of a list, and this is where you will be working for the most time. So it kind of makes sense to put it all the way up. We will extract all of the template files, preferably using a template language like Twig, but you don't have to. Like every single change is a win. You don't have to go all the way, but it's one of the things that you could improve. We will also use a front controller. The like I said, instead of having multiple files, we will route everything through the same front controller. So we are shifting the responsibility of routing, like which file should be responsible, to PHP application. So this is also a kind of paradigm shift by itself. And the things I will not talk about today, just because I wanted to keep the talk kind of contained within the topic, is adding tests. So ideally, you should be adding tests. Not ideal, like you really should be adding tests. So now we have a very segregated, really neat, and very organized structure. We know where the application logic is. We know where the configuration is. We know asset files, test dependencies, they're together. But if we were to add more mature application, if you were to make it a more mature application, we will also have auxiliary files like build files. So Git specific things, sometimes automation, all the files like this. So this would be the final goal and the final picture that we are aiming for. So let's do the first thing. We will consolidate configuration. So remember the last example we used with all of the configuration values, all of the credentials baked into the same file. So this is obviously something wrong with the application. And we will also have to deal with file upload, for example. This is the file upload destination, and you probably don't realize, but this is also a configuration. Sometimes even things like the URL of the application, it's also part of the configuration that we're trying to extract to a complete new page. So let me see if my camera is working. Oh yeah, it is working. Okay, so in this step, we will focus on the configuration files, and we are using a file called git ignore. This is the idea is we tell Git, or this is assuming that we are using Git to version control. We don't want to commit our config/settings.php file. And like I said, this is highly opinionated. But the general idea is we have a settings.php file that will contain all of the configuration values. Everything that belongs to this application, we put them to the same file. Don't worry if the file gets too big. If you have 200 configuration values, we will deal with this later. So first step, we extract all of the configuration values to a single file. And then we will go through all of the places that we had these baked in or hard-coded configuration values. And we have to include the settings file because we need to import the settings file, the settings array, and then we replace them with the values that come from the settings.php file. So we go through everything. So for example, we had the upload directory that had var.uploads baked in. Now we use a dynamic variable, so it's very easy to change. And the same goes here. The nice thing about using a PHP file is if you're using opcache, and as long as you return an array, opcache will cache this the whole array for you. So it's really fast. You can see this pattern that Composer uses as well. So all the Composer autoload files there in a single array, and it's very fast to do. It's a more micro optimization, but now it's one of the extra benefits from this. Next step, we will use Composer and autoloading. So why bother with Composer though? The the first thing is we have a unified way and a unified place to communicate application information. What's the name of your application? You know where to look. In fact, PHP Storm, for example, it can go take a look at your composer.json file, and it will figure out most of the things just for you, just by looking at the composer.json file. And you can declare all of your dependencies, and you can also enforce it to have to have composer to reject running the application. If you're here, we are saying we really need PHP 8.2 or higher, and we really need PDO and maybe string extensions, and composer will refuse to run if you don't have these extensions. So you don't have to check them by yourself. Composer will do most of these things for us. And next we have dependency management. All of your dependencies, Composer will know the whole tree of dependencies. For example, we are here using pass down library. If pass down requires another dependency, Composer knows to download that as well. It's very easy to update. Sorry. It comes with auto-loading support, and if you're using Composer 2.5, I think, it also has security auditing, so it can easily show you if there was a problem with one of the libraries that you're using. You can use them for statistics and analysis as well. You can know which library that you use the most in your organization if you want to fund them, for example. And finally, we can use Composer, most importantly, really, as the autoloader. So here, in this example, we are saying we are following PSR4 naming convention, but you don't have to do this because legacy applications, it probably does not follow any of the naming conventions. So we use a feature called class map, which basically tells Composer, hey, can you go take a look at our app src folder and scan everything. So here we have class PHP files with multiple naming conventions that Composer can go scan all of these PHP files and also .inc files to figure out which files have PHP classes, interfaces, traits, enums, everything, and it will have a list. So Composer is really smart, really flexible, and it's just saves you tons of time. So now we just have to include the autoloader that comes with Composer, just one require file, and you can get rid of every single individual require statements. These changes are some of the most satisfying changes to make, because it means you add one new line and then you delete like 25 lines. So these are like some of the best commits to make, my favorite commits to make, really. So instead of doing autoload on individual file, I would recommend you to have app/bootstrap.php file, which we, on the next steps, we will add more stuff. So let's not call the autoloader right away. We include the bootstrap file, and from bootstrap file, it will include the autoload. So a fair warning though, refactor only when one file has only one class. We will refactor these things later, but for now, on this step, I want you to only refactor if a file contains one class. They should not modify state, as in they should not show any data to the user. They should not call APIs, for example. And calling the constructor should have no side effects. This is to mean that if you call a constructor and if it shows something to the user, these are not the best things to refactor. So just keep them in mind. We will work on them later. And next, we will deal with error handling. So this also used to be a thing. I used to hate things like this, because the idea is you try to connect your database, and then if it returns false, we just ask, just die. That's as horrifying as it sounds. It would just stop the whole script. It does not give you a chance to recover. It does not give you a chance to log anything. It just die. So, but although this, you can find things like this on Stack Overflow even today. Go there, type MySQLite Connect, and you probably will have 10 examples that do this very same thing. But this is awful. It prevents the rest of the application from running. It shows that there was a problem to the user, and then you just don't know when it happens because we don't have any logs. The same goes with PDO. It's slightly better, but it also throws an exception. So the general principle that I suggest you is we do not show any errors to the user because it's not helpful for them, and it also gives you internal information about your application that you should not do to other people. And on the other hand, we should be aware of all of the errors as well. So we do not show anything, but we log everything. So these are the INI values, the basic error handling INI values for production servers. Don't think too much, go with them. So you don't want showing errors, but you want to log every single error messages. But also you can use what we call a global error handler. So using call like this, you can say, I want to set an error handler. Every time there's an error, a warning, deprecation value, whatever, call this function. And within this function, we can decide what to do with this error. Do we want to log them to a separate file if you are not using the standard PHP logs, or send them to an external server, for example? You can also use exception handlers. This is kind of important, really, because if you have an exception, you really should not show the exception to the user. Instead, we need to handle the exception from our error handler. It's on this very specific function, and then we can log this exception. We can log why it happened, where it happened, what time, what are the context values we have, and then we can send an HTTP 500 response to the user if that was a HTTP request, and we can send the appropriate error messages as well. So if that was a REST API call, we send a JSON response, not standard HTML. So this is a more nicer way of handling exceptions. And PHP 8.1, we also have first-class callable syntax. First-class callable syntax. So it looks kind of nicer. I just wanted to include because I'm very excited about this feature in 8.1. So in the same bootstrap.php file, we will register these global error handlers. And instead of doing this, instead of calling MySQLi and just dying in the case of a database failure or connection failure, now we try to be graceful. We try to connect, and if the connection return value is false, then we throw an exception. MySQLi actually has this feature built in. We are telling MySQLi if there was any error in any of the connection when you try to connect or when you try to run an SQL query, if there was an error, I'm telling MySQLi to throw an exception for us. So look for places that you can optimize, look for places that you can throw exceptions, and because you have a global error handler, now you can throw exceptions. Don't throw exceptions where it's not necessary. Then instead of dying abruptly the script, now you can handle it more gracefully. So let's take a look at the next step. Remember, like when we used autoloader, we did not refactor the old classes when the file had multiple classes in there or when there were state changes. This is the step that we changed them. The first step, I would like to show what we are trying to achieve. So the idea is a single file, a single .php file. It will have only one class inside. So this is the rule. Every time you have a class, it's on a separate file. And the name of the class, it should match the name of the file, or the other way around. And if we are using namespaces, the folder of this class, it should match the namespace. This is basically PSR for naming convention. So we go from old archaic multiple classes in the same file, and then we extract individual classes, we consolidate them into individual nicely named PSR4 classes. So now we can guess what's the name of this file should be. This interface, payment right interface, it's on the same namespace. So by the convention, it should be on app SRC, shopping cart, payment methods, payment provider interface. So Composer can figure out as well. And on the next step, we declare all of the dependencies for the class on the constructor. You're not supposed to create new instances. For example, you don't create new database connections inside the class. You are supposed to take them as a parameter in the constructor. So whoever calls this calls, for example, if you're using ideal payment handler, it needs to use an HTTP client instance. And this class is not supposed to create this instance. It can just ask to be provided with this instance, and then it knows how to deal with this. And also, you're not supposed to change any of the global state. So within this class, it's not going to have any side effects. It's very self-contained from the functionality, and all the dependencies that you need, you take as parameters, which will be useful on the next step. In fact, PHP Storm, so thanks Brent for PHP Storm, I guess. PHP Storm has a feature, I mean, it had many features, but one of the features that I use frequently is this rename tool. You can rename a class, and it will look for all of the references to the class, and it will change all of the names and references to this class, which is really nice. And it can also warn you if there's a problem, if there's a mismatch between the name of the class and the file name. So it can also show you that. So more reasons to use PHP Storm. But I guess many IDEs worth their salt should have features like this. Let's also talk about functions. If you see a set of functions that you can extract to a separate place, you can use them as static functions. This is kind of controversial, but as long as you don't have static properties, this still should be okay. So the names are more concise. They are more neatly organized, basically. They share the common name, and you can also use them to autoload, so you don't have to call require on these function files. Just leave Composer to take care of the autoloading. You can also change the visibility. So what you don't do is allow all of the classes. You can enable the classes that you want outside callers to use, and then you can also hide internal functions within the class. Now that we have all of the dependencies extracted, we can use what we call dependency injection container. The idea is that on the db.inc file, we take the configuration from the settings.php file, but what we do on this step is, what if we consolidated these things? Because you might have 30 files that sometimes it creates database connections, sometimes you create a new email instance, sometimes you have memory cache class instances sprinkled everywhere in the class, everywhere in the application. The idea is we use a central location to define how we create these reusable services or reusable components. Here I'm using a library called PHP It's one of the simplest containers. It's similar to Pimple from Symfony, from Silex, I think. But PHP is much more maintained. So you start by defining how you create these instances. So we are giving a name, database, and then here we have on the container, we try to create, try to get an instance of the database. And here we are defining how you can create this instance. The idea is PHP will keep a copy of this database object for you. And when you need it, it will create this and send this to the caller. But if someone else asks for this, it will send the same copy. So it's not going to create 10 different database connections. It will return the same thing when you need it. Right now, this is more like service locator pattern. We are going to change them. But for now, this is still an improvement over having multiple files that create these services. And the settings themselves can come from as part of the container as well. So here we are taking the settings as part of the container. So everything is in the same place, including all of the settings. You can define more services you need. So here we have a database, and the next one we create a mailer instance. This is just examples. Don't think too much about it, but the general idea is we have a central place to define all of the things we need. And settings come like this. And you can have cyclic dependencies. For example, if the mailer depends on database, you can ask for the database, which will in turn go for the settings array as well. So, and settings comes from the settings file. All these dependencies, we can contain them in a separate file called, say, app.dependencies.php file. And from Bootstrap file, we can use these dependencies. So Bootstrap file, it gets all of the Bootstrap logic step by step. And on the next step, we try to separate the business logic from the view logic. And the idea is simple. We have a very messy file that it changes the application state. It has error handling built in. It handles errors, and also it has database access that takes values, and then another data validation. We also have, well, another data validation. Also, it changes the database state, and at the end, it shows the value. So the actual presentation is here, but we also have so much things happening on the same file. The rules is not rules, like the recommendations is that don't throw exceptions everywhere, and don't handle all the HTTP methods on the same file. Separate them. And on the view layer, you're not supposed to go take additional database calls, no API calls. It's strictly separated. We consolidate all of the validation rules to the same place. And if it's possible, don't use get and post values directly. Try to abstract them so it's very easy to test on the next steps eventually. Again, I'm using PHP League, plates.php library. It's one of the simplest PHP template engines you have. You define where to find the template files, and then you pass all of the values. And within the template, you can declare your logic, like how you want to present the data. Plates.php, it also has some useful features like escaping. So if there's an HTML here, it will escape all of the HTML. So it's also secure as well. And finally, we will make use of our front controller. So going all the way back to the same example, you had the CSS file that just asked for everything directly, but now we have this structure. It's more organized now. And what we try to do is to send everything through this index.php file. How do we do this? Well, every web server, they have, not every web server, but every web server worth using. Sorry. Apache, for example, it has a feature you're telling for example.com, look for the files here. So var example.com/public, which is here. And we also define a rule saying if the request file does not exist, and if the request file does not match a directory name, and the extension does not match JPEG or CSS or any of these static file names, I want you to send this request to index.php. This is the two most basic configuration we need. And in fact, most of the servers have this. Nginx, Caddy server, they also have the same idea that we take a request and then we route it to the index.php file. And from within the PHP script or the PHP request, we look for the request method, and then we look for the request path, and then we have a list of routes that we use, and then we send it to a class, a function name. So here we have get, it matches here. Get request, so we are telling get request to login.php. It's handled by app controllers, uses login page controller. Slim.php has one of the simplest and easiest ways to explain this idea. It uses fast route from Nikik that Nikita we talked with Brent before. You can define all of the routes that you deal with and then map them to a specific class. So all the requests to login.php go for this class. Ideally, we want to put all of these routes to a file called routes.php, and also use the dependencies.php file to show when you need a login page controller. Now you can declare how you can get this instance. So instead of loading individual services, for example, the database or the template engine, now we do this on the dependencies.php file. So this is what we call dependency injection, because we are injecting the dependencies as opposed to locating these services. So in the login page controller, you can declare all of the dependencies. So here we define or declare all of the dependencies we need. We separate the business logic from the presentation logic. So this is strictly handled by the template engine, and we throw exceptions where it's appropriate. So going back to this example, to summarize, we extract all of the dependencies, we extract all of our routes, and we tie everything together from this bootstrap file, which brings us to what we were looking for from the beginning. Everything separated, the application logic, you know where to look for. Configuration is on a very specific place. Static files are in where they belong. We also try to add tests, and we separate and clearly defined dependencies. So this is what I would like to bring you today. But there's also next steps. For example, I would like to propose to use unit tests where appropriate and where possible. These are some of the highest battle-tested tools. And the other things that I personally had so much win.
Ayesh,
Yeah.
sorry to interlude, but can you speed a little bit just to final remarks?
Yeah.
Maybe.
I'm on like 3 last slides.
Okay.
5 last slides. Yeah. Sorry. Thanks.
Okay.
And
See you in a bit.
yeah. Thanks. We try to use external tools that you can replace. For example, DOM.pdf, that's a very old PHP library. Try to replace them with something nicer. Replace Jenkins with something nicer. Try to use Docker when you can. For all of this, I have a few resources that I would like to propose you take a look. Some of these books are really nice. This one's really nice. Martin Fowler's books and all of the blog posts are really nice. And Modernize Legacy Applications from Paul M. Jones was also really nice, but it's kind of outdated now. If you have any questions, I will be reachable on all of these places and also on Slack. Unfortunately, I'm out of time. I'm late by 6 minutes, so I wouldn't have time. But thank you for everyone for coming. Thanks to Andrew for captions. I think I wasn't talking too fast. And thanks to everyone for coming. And speak like Ethan. And back to you,
Yeah.
Kaneka.
Thanks for that. It was really extensive, and you did your talk a bit. Oh, I forgot the punchline. Shoot, in every bit. So we probably know by now how to properly eat an elephant. So thanks for that, and sorry for don't pull any questions because we are a little bit on time. But you're gonna be on Slack answering all the questions. I'm pretty sure of
Yeah,
that. So thanks for that, and I'll see
yeah.
you
Thanks so
next
much.
year. Bye
See you
bye.
next year.
Bye
Bye.
bye.